In this video, I'm going to be talking about how you would go about locating your absolute extrema on a closed interval. Alright, and I've emphasized here it's got to be a closed interval. This process will work when you are dealing with a closed interval. Alright, now what we're going to be doing is we're going to be taking a look at our extreme value theorem. It says if a function is continuous on that closed interval from a to b, then f of x has both a max and a min. So we're guaranteed of a maximum min. Alright, now you need to realize that on this closed interval, your absolute extrema are going to occur either at your endpoints or at a critical number. Okay, so you're going to first need to take your derivative, find those critical numbers, and then test the only possibilities of where that absolute extrema could occur. Alright, the absolute extrema can occur either at the endpoints or at the critical numbers. Okay, so on this first example here, I've got just a nice little polynomial curve. Alright, polynomial curves are continuous. Alright, so definitely it's going to be continuous on this interval from -1 to 2. Alright, so the first thing I'm going to do is I'm going to find my critical numbers. So find critical numbers. Alright, and the way I'm going to go about doing that is I'm going to take the derivative and set it equal to 0. So my derivative of f prime of x is going to be a 12x to the third and then minus a 12x squared. Alright, now to find those critical numbers, I'm going to take that derivative and I'm going to set it equal to 0. So 12x to the third minus 12x squared equals 0. I'm going to take out a greatest common factor there because factoring this is going to be the easiest way to solve this. So 12x squared. I take it out of that first term, I'll be left with an x. I take it out of the second term, I'll be left with a 1. Now we're going to set both of these equal to 0. When I set 12x squared equal to 0, then that tells me x equals 0. When I set this term equal to 0, x minus 1, then I get x equals 1. Alright, so x equals 0, x equals 1 are my critical numbers for this function. Okay, so that's an important thing. Alright, now I'm going to try to locate that absolute extrema, okay? The only places that the absolute extrema can occur on a closed interval would be at these two critical numbers or at the two endpoints. So let's write down what we're going to do here. We're going to test our critical numbers and endpoints in the original equation. And I think sometimes students forget that they're supposed to plug it back into that original function. Okay, because what are we talking about? We're wanting the absolute extrema. So we're wanting maximum points, minimum points of the original function, not of the derivative. Okay, so plugging that back into the original function is going to be extremely important here. So I'm going to make just a nice little simple XY table. Okay, and I'm going to put in these critical numbers. So I'm going to put in 0, and I'm going to put in a 1, and then I'm going to put in my endpoints. So -1 and 2. Alright, and then let's identify what these are. Okay, these are my critical numbers. Kind of writing kind of small here. And these are my endpoints. Okay, so those are everything that you're going to test. Alright, so it's a matter of plugging 0 in. Well, if I plug 0 in there and I plug 0 in there, I get a 0. Okay, then if I plug in 1, alright, then I'm going to have 3 minus 4. That's going to give me a -1. If I plug in a -1, that'll leave this term positive. That'll make this a negative. So plus plus, that's going to give me a 7. And then if I plug in 2 times 3, plug in 2 there, I'm going to get a 16. Alright, so now what I'm going to do is I'm going to look at these f of x values because that's going to tell me where my absolute extrema is. It's going to tell me where my max point is, how high it goes up on the y, or how low it goes down on the y-axis. So 16 is my biggest number right here. So then that means I have an absolute extrema. I have a max at the point 216. And looking at this list, this -1 is the smallest, so that's going to give me a minimum value on there. So I know one of my absolute extrema will be a minimum, and it's going to be located at 1, -1. Alright, so a nice little straightforward way to find your absolute extrema on a closed interval. Alright, make sure that your function is continuous, especially continuous in that given interval. Alright, find your critical numbers by taking the derivative set equal to 0 and find them, and then test all your critical values and your endpoints in that original function, because that's going to be your possibility for your absolute extrema. So one little example here, just try to make it straightforward for you. Definitely thanks for watching, and don't forget to subscribe to the channel. Thanks.